Okay, let's see if I can get it. Oh yeah, that's a crack. So you're gonna need some reinforcement on this torsion backing plate. These cracks develop. See, there's some cracks there. This one just totally came off. There's a crack. There's a crack. So the torsion plate. So what you can just get your stock plate and take like a 1 millimeter 29 by 1.5 millimeter steel filler. It's the exact same diameter. You just add on that extra steel to give you added protection, right? And it stays under your lip here. So you got these torsion ring lips. There's a lip there, these lips right here. It's well under there, but it adds just enough. See, they addressed it previously, and this one developed. That one developed. Focus. Yeah, just from the sheer force of that. See, it's changing vertical to circular force on 2 axes, right? The clutch and the transmission and the crank. These are your torsion springs for your clutch. So you just take 2 rings and braze them in here, and that'll give you the extra. That'll give you the extra torque strength when those springs torque back like that when it's transferring the power. Then they won't crack. But just the stock one, 660 on a 686, they're just gonna crack from all the horsepower and torque. So yeah, these torsion springs help manage the torque, right? So to keep them from cracking, yeah, just get a new backing plate, take these steel rings and braze them on there. And then that should keep you from cracking. You can run it full power. Because you're doing like high RPMs. You're asking for top end clutch, right? So you can like take off at 80, 85 miles an hour, open it up. So when it asks for that torque, depending on what gear you're in, even in low gear, it'll ask for torque, right? So you get up in 4th gear and you open it up, go into 5th gear, and all that torque takes off. You know, like you see those guys doing wheelies at 90 miles an hour. Well, they got steer stabilizers, but they need to address the clutch, so it's backing, so you don't end up with clutch parts in your darn oil system and what have you. Okay, that ought to do it. Good luck with your conversion. Yeah, that's just to bring the 660 up to a 700. You had to modify or get a. Golly, they probably could have go with some titanium. That's expensive, like aircraft material. No, that's good enough for government work. Okay, talk to you later. Bye for now. Oh yeah, so as I was saying, yeah, I got it prepped. Got it all polished up, prepped. Got some clamp. Got 3 clamps on there. Just to get some these SSF 16 brazers, 7,000 pounds per square inch. You just bring up the. You're adding that steel in there to keep it from cracking. You're adding like 7,000 pounds per square inch of, that's the torque. That's a torque, that's why they call them torsion springs. Because the torque is transferred through the springs, torque and torsion, the same way, so, but, yeah, you want to reinforce it if you're going from 660 to 686. It's just too much horsepower for that little back plate. That just holds these springs on, right? And then, what are we addressing here? We addressed this, we got the steel oil pump. We're trying to figure out the redundancy of this gear, but it's not redundant. It looks redundant, but it's actually doing 2 purposes. It's spacing the distance between the drive axle and the crank axle when the clutch actually engages. Because down here on this gear, right, that's going to be your free spinning crank. Right, that free spins with the crank. And as the crank turns, the oil pump turns, see? They're connected. So they were all geared out, and it looks like they just machined that off to slide this oil gear on. I don't want to pull it off because I got Teflon in there. So it's tight. Well, for some reason, when you slide this in, boom, I was getting 1 millimeter of play, but see, it sets up a spacing, right? Then your torsion plate goes under that oil gear, and it sits up right here. See, here's your it's 19 millimeter if you ever want to remove it. Wait, no, that's 7/16, 13/16. Fits right in there. So you can pop that gear out if you need to get to taking apart this clutch. But then, yeah, that gear is like setting the distance to the in there where this thrust washer. It mates up with that thrust washer, right? Because when you put the basket on. Put the basket on, right? Boom. Then you'll have your thrust washer. And it creates just enough space between, like I was saying, the drive axle and the crank axle, right? Because beyond this point is the north of this thrust washer is the crank, right? And south is the drive axle. Crank axle and drive axle. That's why they got the clutches here. The clutches ride on the basket, which is the drive axle, and the steels ride on the clutch hub, right? And they're held in by the pressure plate. Yeah, the steels ride on the clutch hub, which are torqued down. So now you got the that would be the hub. That would be the when it's engaged, and it also lines up to the actual clutch cable connector. So that gear is kind of like, it's not redundant. It creates a space to line up with that thrust washer and the oil gear. And then this is your crank gear, right? This spins with the crank, right? So, and the steels are in between the clutches, these little white tab ones, and they're spinning on the outer axis, right? They actually engage on this axis. There's two axes there, right? So the inner one's spinning freely. See, this inner high velocity seal is on. It just spins freely, right, on the axis. But when this engages, it actually grabs the teeth of the drive axle. So the clutch hub connects to the drive axle, and the thrust washer is kind of like the border. It's on neither axis, but it just creates enough distance to separate the two. Because see, below the thrust washer is the drive axle, but above the thrust washer are the steel plates, which are engaged with the drive axle, right? Yeah, because that connects to the drive axle. But this is spinning freely, right? This spins freely on the drive axle. This one doesn't. So, when they engage this big gear, engages. So to disengage that gear, you pull up on the pressure plate, remove the pressure off the pressure plate, and there's two independent spinning axes. But until you pull on the pressure plate, there's one axis, and they're being managed by these torsion springs, right? The two axes transfer their power through the torsion springs. So yeah, this is getting into the nitty gritty, because that connects right there on the, that's your clutch lever. See the teeth? So your clutch lever, this connects to the clutch lever. The clutch lever engages the pressure plate. So yeah, that's right there. Clutch lever. So we got that. We have got some work done on it. Pretty nice, huh? That's your oil filter and your water pump. So this is like your rear main seal, right? Because the oil's fed in through here and it goes into your drive axle, right? Because the oil pump is a dual sump push pull hydraulic pump, right? So number one of the oil pump draws from the oil bottom to the crank. Splash feeds tranny, gear and decks in the balance, right? But the number two pushes through the oil filter, the head via the number two delivery, the main axle, and oil tank lid. So here, you see the oil gets pushed. It gets pushed through that oil filter, then it keeps getting pushed through. There's a hole at the top there. See if I can catch it. Well, that hole. Let's see, here's that hole. Gets pushed through there, and it gets pushed through that hole too, which is right here. And that goes up to your head. So the oil is being pushed through the oil filter into here, out this pipe to the head. It's being pushed into this main oil seal, which is the main axle. So oil is your main axle, right? Then here's, yeah, this is the check valve. See, this check valve goes in here. Just put a spring in there, right? And a ball bearing and a seal. So the oil is pushed through this check valve, right? Whoop, lost it. There's your bearing. So the oil is pushed through this check valve. Then it continues up, pushed through there, continues to here, climbs up here, climbs into the oil filter, right? Gets filtered, comes out here, is pushed out here, and pushed out back to the oil, to the top of the oil reservoir, the oil tank lid. And the other one draws from the bottom of the tank to the crank splash. That's on the engine over there. But this is the number two line, right? So this goes to the top of the oil tank, this goes to the top of the head. It's being pushed through this check valve, through this hole up here. back that you see comes back down into the, there's like a oil feed and oil channels, and this does the gear housing and the main axle too. This is right down there by your gear shifter, right? There's your gear shifter. Oh, poor lighting. There's the oil pump. And there's the hole. That's like your rear main oil seal. This little, it's got a hole in there, right? The feeder hole to feed all the main gear, balancer, drive axle. So, that was just some notes on this. And then, yeah, so this clutch rides in here. It'll ride in there like that. Boom. Boom to boom, thrust washer. Like I said, we got it all new paint job. Got some enamel, yellow and blue enamel. Oh, enamel's good enough for me. And you want to get the high tension torque bolts, because stock 700 is 10 to 1, stock 660 is 9 to 1, and this is going up to 11 to 1. So you definitely need the high performance head bolts. This is going to crank down a little bit tighter, not much, but just enough to where there's going to be less space and more compression. So there's going to be a lot more everything. Okay, here's this. That's your Weisco forged. No, it's not forged, it's cast. Wait, no, it's forged. Yeah, cast is just machined aluminum. If it's forged aluminum, then it's actually done through a lost wax. It's a different casting method. Makes it stronger, and then it's also, yeah, so these arms don't groove and pit, and then it's also Teflon coated. So these clutches won't tend to, they want to tend to create dimples on a standard clutch. These are upgraded fibers, O'Neill dirt diggers. So yeah, this is the main axle connect. And underneath the thrust washer, right, it's just separate. See if I can get this out. Just like so. There it goes. That's your, oh, I guess I'll just redo the Teflon. It was perfect on there. That's your oil gear. The idea, well, also going to use, you actually want it gasket. You want to completely, the Teflon is heat resistant. I mean, you could do some like 300 PSI stuff with that Teflon. It just holds up for, water systems use it. All sorts of systems use Teflon just to bridge that little narrow gap. So there's one layers, right? So some gasket, and then it'll be in here. Like I said, there's like a 1 millimeter of play for some reason. So there's not supposed to be no play in there. Well, not in my part. So put your torsion plate on, put your oil, set this, it sets the distance right, flip it over, your basket will be connected, thrust washer, clutch boss, pressure plate, and clutch connector. We got one of those too around here somewhere. So that's your, that's a clutch cable. It connects to the housing of the frame. So it bolts right there to the clutch cable. I put some washers on here for some reason. I just don't feel safe with, just like these two little nuts holding this entire clutch cable on. So I give it a little bit more space for more tension. I can torque these down really good to that. Crank it down really hard to that case right there. It connects to the case right here. Bada boom, bada boom. Right. That connects to the case right there. Then it bolts. You got your two holes lined up. Then the clutch cable bolts to it, and then you can just screw your oil filter and water pump on. And the water pump goes to the head, right? Water pump connects right here. And to the radiator. It goes right there. So those are your two water pump connections, your oil pump, your oil pipe number 1, number 2, and number 1's down there. So that one's the one that's sucking from the oil pan. And it fills that housing, and it splash coats the, what is it called? It's got splashers on the crank for the pistons, so the pistons oil. I forget what they call them. Yeah, just splashers. Oil delivery. Use crank splashers. Yeah, they got splashers for the crank, and they got splashers for the case. And they got all sorts of channels and cavities in there. That's going to be your push line, because it pushes through that check valve, right? So there's no pressure differentials gaining on the pump, right? Because one pushes and one pulls, and one's got a check valve just so they don't ever form a conflict, right? Because if one gets back pressure or clogged up there, it keeps the pressures from conflicting. So if this side gets lower pressure, it's not going to come back through that ball. or higher, vice versa. Yeah, so we got it all set up, ready to, these will be here Friday. So I hope that was some help on your 660 to 700 conversion. That's the matching waistcoat piston and clutch. You gotta upgrade the clutch when you upgrade. That's a 11-to-1 piston, right? So, well, that's at least what the box says. So that'd be some advice how to do that if you're putting it back together. How the oil system runs through this case. One pushes, one pulls, goes through the filter back to the top of the oil tank, and that one is sucking from the bottom of the oil tank. And how you want to make sure that's going to meet standards for the torque you're adding with the, well, you're going up 11-to-1 compression. You're just gaining a ton of horsepower. It's like a whole different machine, in my opinion. 700 is a totally different machine. Upgrade the steel pumps. Okay, so good luck with your build. Hope that helped how you could assemble that and address making that stronger. You have to make that stronger no matter what. These cracks, it's just pulling too much horsepower. See that it's cracked. That's because they never upgraded this, but they upgraded the power that it's supposed to manage, and it just couldn't. It petered out. Okay, thanks for tuning in. Bye for now.